Internet, hello. Today we're going to do something a little different. I've been reading a book, I think it's called Network Security Monitoring or something like that, and in this book you talk about a variety of different tools that a security analyst or a SOC would use. And one of the specific tools that he talks about in the beginning of the book is a whole kind of plethora of protocol analyzers or packet sniffers. And one of the tools he talks about initially is TCP dump, so I decided to dive into that tool as I progress through the book. So today I wanted to share with you traffic dumps and TCP dump, some of the stuff I discovered when reading the book, but also doing a little bit of research on the side to get more hands-on practice and see what it's about, why it exists, etc. So TCP dump, here we go. I wanted to talk to you about the why, the what, and how, basically. And the reason I wanted to start with the why is that all the tutorials I found specifically on TCP dump, they all focused on the what and how. So they really focused on the technology, how to use it, what it was, etc. But they never really talked about why it was useful and the use cases of how it would be applied in the real world. So TCP dump, what is it? So TCP dump is basically a subset, or really the grandfather of packet sniffers. So a packet sniffer is, here we go. We got a little Ice Age cartoon and some cars. So the sniffer is basically sniffing traffic, and each one of those cars in this GIF right here can be basically labeled as packets of information. So as little packets of information are going across the network, we have these sniffers that actually can sniff the traffic, and actually what they're doing is they're duplicating the traffic. So they're taking maybe either through this thing called a tap, which basically it's kind of like wiretapping but for network. So you plug in this tap into your network and it basically mirrors all of the traffic onto this tap, so your packet sniffer can actually analyze that traffic. And then another way to do it is if you don't have a tap or a massive network to analyze, like myself and most of you, you just use your network interface card on a computer. And it's that network interface card is basically our computer's way to talk to other computers. And we use it in a way called promiscuous mode. So we're actually able to see all the traffic around us instead of the traffic that's dedicated to us only. So packet sniffers basically sniff packets across the network, and they analyze them. And I'm going to talk a bit more about that. So why TCP dump? TCP dump actually started back in the day, 1988. So in 1988, there was a group of individuals at the National Something Something Laboratory, I don't remember the name of it, a very famous place, obviously. And they created TCP dump to sniff packets across different networks back in the day. And what they wanted to do is they wanted to make sure that this was adopted widely. So they created this open source library that could be accessible through APIs. And this open source library was called libcap. And libcap was basically the seed and the origin of all the packet analyzers and packet sniffers, not all of them, but most of them, that we use today. And not just packet sniffers, but a variety of products. And what I found here is all of these tools here I've listed here. So Zeek is the new version of Bro IDS, an intrusion detection system. Snort, another IDS. McAfee, and also Wireshark. All of these tools that everyone uses on a day-to-day basis, at the very origin, not the origin, but one of the core features is libcap, or a version of libcap that was created by TCP dump. So TCP dump is kind of the old school version of a lot of this stuff and a lot less features. So with that said, what is it used for? What is TCP dump used for? There's three major things I came across. So the first and foremost is learning. So a lot of people use TCP dump as a learning tool, and they use it so they can actually learn how to interpret and understand packet information, so they can kind of see the traffic going back and forth between networks and really understanding how to break that down and understand what's happening and seeing the bits and bytes of all that. And then the other piece is filtering. And with filtering, it's really useful because you can actually add a whole bunch of different filters on the command that you do in TCP dump to filter down the different packets that you want to observe. So learning is the first one. Next one's automation. So like I said, a lot of these tools that we use today, the more modern packet sniffers or protocol analyzers, etc., they tend to have probably some sort of script that automates a lot of the sniffing on your network via TCP dump, and then they port that into their software to analyze in a more easier and user-friendly way. And actually, for automation, another one is when you're analyzing traffic for a headless machine that's remote, so it could be something that doesn't have a GUI, it's just maybe a server sitting by itself in a far-off location, you can actually use this to script different types of pools and sniffs from the network in that location. Next one is investigation. So when you're attacked, because most networks are attacked all the time, when you're attacked, you're analyzing how the attack happened, when it happened, who did it, what's the impact, etc. Well, when you're going across and throughout this process, you basically drill down over time. So you start out with like a broad brushstroke of saying, this is what we think happened, and then you drill further and further and further down. And in the book I told you about that I'm reading, The Practice of Network Security Monitoring, he actually goes through two different scenarios. And in both of those, they use a version of TCP dump, or they use TCP dump directly within this process to really narrow down on a specific piece of traffic to see exactly who's interacting with who and what information is being sent at what time. That's another use for this in the real world. So what is it? So this is basically a very generic TCP pool from a SNF, or a packet analyzation. And what I've done is I color-coded it, because at first this can be extremely overwhelming to anybody new, especially me. So color-coding it and kind of breaking down the different pieces of what they mean is quite useful for me, and I thought it'd be useful for you. So this is just a simple piece of traffic that's been sent across, that's been sniffed by TCP dump. So the color codes we'll start with here. So the first is the timestamp. So you can see that it's at 8:41 with 13 seconds. And then the other number after that is actually, I think it's the fraction of time after midnight or something like that. It's very strange. The next one is the network layer protocol. So here you can see that we have the IP protocol. And I think here they show the IPv4 and v6 on this piece. Next, you have this green section, which is the source IP address and the source port, and also the destination IP address and destination port. You can see that here where it has the last, for the source, you can see that it's port 22, which is SSH, and then the other port is 4196, which I'm not sure what that is. The next one is a TCP flag. So these flags are basically built for TCP. So TCP has a variety of flags telling you if something's been, there's a SYNAC, and then a SYN, and then a finish, etc. So here we have a TCP flag for a P and a period. So the P is push and the period is acknowledgement. And in the post I've written, which you should go see, has a whole table for that. The next one is the sequence number. So the sequence number is basically showing you the length of this packet, and it's also showing you the sequence of the packets being sent. So the purpose of the sequence number is to tell you how the packets are being sent over time and making sure they're all kind of chronologically in order. And here you can see this packet started at byte 196 and ended at byte 168. There's a lot more to it, but generally that's what it is. The ACK1, so when you're sending a message, the acknowledgement usually is a 1, and when you're receiving a message in TCP, this section, the acknowledgement, is actually the expected byte you're going to receive. So for this specifically, it ends in 568, so if I'm receiving this package, I should have an acknowledgement when the receivement piece is going to be an acknowledgement of 568 instead of 1, because I'm receiving. Win309 is the window size. So that's basically saying, the window size is basically, it's like an advertisement from the receiving machine saying how many bytes this machine can receive, and this is saying that it can receive 309. Next we have the other TCP options. So there's a bunch of random options, not random, but a bunch of options that can be used. Some common ones I came across were scaling the window size and also maximum size, something, it's MSS. And then the last piece I've got here is the packet length. This is basically showing the length of the packet, and you can derive this length by basically subtracting the sequence number, so the start and the end sequence. So 568 minus 196 is 372, and that shows you just basically in bytes how long the packet is. So that's what we're sniffing. So how do we sniff it? Here's a basic command that I'm going to show you. So anytime you're using TCP dump, you have to be an admin or root. So either you use sudo before you do it, or you're the root user. And with this command, actually, I should back up. Every command I've come across tends to have three things. They have the command that's being asked. They have switches that are basically additional options that you can play around with, and they also have filters to filter down what kind of traffic you want to see. And here we have a bit of each. So the first piece is the TCP dump, which is the command that you're saying. The next thing is the I, which is talking about the interface. So remember I talked about the NIC on our computers. That's basically observing the network interface card. It's promiscuous. So right here we're saying that this interface card, ours is ETH-0, which is most Linux users, and that's going to be Ethernet 0. We're basically looking through this NIC to sniff traffic. The -n is basically removing the mapping of host names to IP addresses and port names to port addresses, because when doing the mapping it takes a lot longer and sometimes it's convoluted, the names. So that a lot of people kind of put this in there. The S is the snap size, I think, and basically what they're doing here is they're snap length, snap size, And what they're doing here is they're basically saying any packet size is allowed by placing a 0 in there. You can also limit it to say snap size, length of whatever, and then you limit your traffic to that size of packet. V is verbose because basically we want to see as much as possible. So if you put a V, you get to see more information. No V, less information. Another V, even more information. And then here's a filter where we're basically saying that we only want to see traffic from port 80. So we're looking only at port 80 traffic here. And you can do this for the host as well. You can do it for IP addresses and protocols, etc. It's one of many filters. And at the end, I want to basically talk about this one thing I took away from this experience is that when looking at a lot of these tutorials and reading through these blogs and books, etc., a lot of people talk about the how and the what, but they never really touch on the why. And the important thing here, I feel, is knowing the why and knowing why it's important a tool is used. So technology is great, but technology is only a means to an end. It's not the end in itself. So SpongeBob is a good lesson. And if we have time, I'm going to show you a real stuff. So we're going to do a sudo TCP dump. We'll do a -i eth0 nn. We'll make it verbose. Then another thing I want to show you is we're actually going to read this into a secret file. So what we're doing here is we're reading this into a file, and we're going to look at it later instead of looking at it right away. And we will do that, hopefully, yeah. Ask me for a password. So I tried to read instead of write. Don't do that. Let's try this again. So R means read, W means write. So we're going to write to this file. So we're going to write to this file, and we're going to send it, to there. So now you can see that it's reading, and like I said, my network doesn't have much traffic because it's only monitoring my device and the traffic basically within this virtual machine that I'm using Linux, I'm assuming. So what we're going to do is we're going to open a browser, which we have here. So open any browser and then just go around clicking links. So we click that link, and then we'll go to YouTube because why not? And you can see this got 42, 23, 520. This is changing. This is the number of packets that are being sent and received at the same time, which is a shyster load. So what we'll do is we'll actually stop that now. And the next thing we want to do is we want to read it. So that mistake I just made, we're not going to make that again because we're going to read it now with this secret file 2. So we're going to do a sudo TCP dump -r is to read. We don't want to see, that's a distraction. We're just going to close that out. Cool. We're going to read this, and hopefully it does what I expect it'll do. And it did. Hooray. So this is basically all the packets that we received and sent, etc. for TCP, or a variety of other protocols, actually. And we'll look at this last one just for an example. And the last one is basically showing the time, like I mentioned. So 7:27:49, the fraction of seconds since midnight, I think. The network layer protocol, IP. Then we have the source and destination of our IP address and port number. So we have our source IP address, which is here, and our source port. And then we have our destination IP address here, and then our destination port, which is 44 or 80 actually. The flag I told you about, this is the acknowledgement one, the period I mentioned, ACK2, no idea. And the window size, and the length of the packet, which is 0, which is interesting. But here you go. I think actually ACK2 is acknowledgement, I have to look into that. But anyways, actually, I want to look at this one here for you, up here. So here, this one highlighted the point that I made around the receiving packet. So you can see this is a sending packet from this address to this address, and this packet that's receiving this, so you can see that it's vice versa now. The ACK that I mentioned last time where it says that it's the receiving bit, you can see that the last bit of this one is here, and the receiving bit is here. That's the point I made around the ACK flag, or the ACK piece of this reading. Anyways, there's a lot of stuff that I want to share with you and I want to learn more about, but we're going to leave it with this one. Internet. I hope that this made sense or is semi-understandable. Go to the post. It's probably way better than this video. Anyways, Internet, I'll see you next week.